All right, welcome back. So we've got our 3 apples unit test and our 5 banana unit test working. Let's go and turn these 2 separate tests into a more compact theory. What I'll do is I'll move up here on the 3 apples unit test and make the changes. Theory, inline data. All right, well, what am I going to make it? Well, what have we got here? We've got the product description, so Apple, we'll want that. We'll want the unit price, 0.35. And we'll want the quantity, so there's 3 of them. And now we've got the theory values, need to create the corresponding parameters on the unit test. So string, product, name, and so it's apple, banana, and so on. Our unit price, decimal unit price. And lastly, int our quantity of the unit. Actually, let me bring those around. And up here in the inline data, we can't specify the decimal with an M. It doesn't like it. We need to specify without the M when it's actually a double, but then we can declare the parameter as a decimal and an automatic conversion will occur. All right, let's make the appropriate replacements. So product name, here we go, parameterize product, and of course we've got Apple in our verification step as well for the cart item. All right, unit price, we've got the 35 cents there, and quantity is 3 and 3. Let me just run it the way it is. I'm not going to replace the total just yet. We'll need to have a little bit of a think about that. Okay, unit tests are running. Okay, they're all passing. Right, yes, what to do? Well, we could go up here and specify the total as a separate value, something like that, and then create a particular parameter for it and then replace it. However, maybe to keep the number of variables in play to a minimum, we could actually say, well, given, in this theory, we're only ever going to have one item, one shopping cart item, which has got a quantity of a particular product. And we know that the total is in fact the quantity multiplied by the product unit price. We could keep things a little bit more fluid by actually specifying the formula for working out the total when you've got a product, which of course is just the quantity multiplied by the unit price. So the 3 apples multiplied by the 35 cents per apple, and so on. I think that looks pretty good. I will run the unit tests to see whether everything is working. Okay, brilliant. The unit test is passing. And I will now grab the 5 bananas data. So inline data, just make the banana, and the price 0.75. That's the unit price per unit, and we had 5 of them. Okay, that should now work. However, the description of the unit test is no longer fitting given 3 apples. It's now more generic given have quantity of product. Actually, let's make that of a product just to indicate that it's a singular. It's either only apples or bananas, not apples and bananas. So have quantity of a product when call add, then have product in cart. Product in cart, that looks good. So have quantity of a product when call add, then have product in cart. That's a nice, somewhat more abstract name for this unit test, but I think that works a-okay. All right, let me run all the unit tests. Brilliant. Both these unit tests, because this theory here is made up of 2 individual unit tests, one for apple, one for banana. Both of these are working and passing. So all unit tests are green. Okay, now given that we have made our code quite generic in our shopping cart, right, we're adding a new shopping cart item made up of the product and the quantity, and we've got our 2 unit tests to kind of prove it. It is nice to add another set of data as a separate test to test this formula, sort of as a forward-looking unit test. So we've created an initial unit test which forced us to write a very specific implementation. So initially it was about 3 apples, and we could hard code our shopping cart item with a product hard coded with with apples and 35 cents and a quantity of 3 of those. Then the second unit test with the 5 bananas forced us to make our code more generic, and now just to sort of show that the code will work for any kind of product, it is useful to create another set of data, what I like to call a forward-looking unit test, to show that our generic implementation code will work for any kind of product. So I'll do this now. So here comes the data for our forward-looking unit test. So inline data, I'm going to make this cantaloupe, and maybe they're $2.50, and we have 11 of them. Let's go with that. That's our next test. All right, let me run the unit test now, or all the unit tests. Brilliant. All the unit tests are passing. So the new test data of cantaloupes that have got a unit price of $2.50, and we've got 11 of them, is all working. And our forward-looking unit test, so a test that just has a different product and a different quantity, and we didn't have to change the implementation code because it was generic enough. This confirmed that behavior, and we're good to go. All right, before I want to go and refactor our unit tests and our implementation code further, I would like to take a minute and just talk about why I choose these odd numbers in my unit tests. You know, why do you use 35 cents for the price of an apple? Why not just make it a clear 1 or something like that, or maybe even kind of like a 2? And, you know, I think if I had done that, if I had set the unit price for an apple to $2, and there was 3 of them, a quantity of 3, it would have meant that the total amount, which in a shopping cart with 1 item in it of 3 apples at $2, the total, which is the product of the unit price multiplied by the quantity, would have been $6. So the integer data type that we had on the total property in our shopping cart would not have needed to be updated to the decimal data type, which is much better at dealing with monetary amounts in dollars and cents. So there wouldn't have been a fractional amount, the cents amount, like we would have had with 3 apples at 35 cents each, which makes a total amount, as we saw, of $1.05. But I like to use prime numbers and odd numbers and sort of weird numbers. You know, like there with a cantaloupe, we have a quantity of 11. Why don't I just choose 10 or 1 or something like that? I like to use sort of weird numbers like that simply because if I do that, then I'm unlikely to end up with a test that automatically passes with the data that we had from a previous test. So just to give you a little bit of an example, if we have apples that cost $2 and we've got 3 of those, and we also say have bananas that cost $3 and we've got 2 of those, the total in either case would end up being $2 multiplied by 3, which is $6 for the apples, and $3 for a banana multiplied by 2, because we've got 2 of them, would also end up being $6. So we can inadvertently have unit tests pass if we tend to choose round integer numbers like that. So this is one of the reasons why I like to go sort of for weirder numbers. Preferably, I really like prime numbers like 11 or 13 or 17 or 7, that kind of thing, because it brings out the sort of unique nature of a test. Alright, let's refactor things a little bit more. I'll see you shortly.